All right, application quiz 4 is due this week, so I wanted to make up something similar to number 4 and go over it. I still have about, let me see, 7 more exam 3s to grade, but I'll make sure to get those done this weekend, okay? But this is due this Sunday, so I wanted to finish it. The first 3 are posted on Canvas, but here's the 4th one on finding average, okay? I think your problem is on average, public awareness of a candidate's name, like do they remember this guy's name after a campaign? So I made up something similar, and I got the idea after grading your exam on, module 3, and I was wondering, will my students remember this thing about elasticity of demand and what it means to the total revenue a year from now? Will you remember this, right? So here's my question that I made up. Whether a student in a Math 261 class remembers exactly what elasticity of demand means to total revenue since the beginning of the 8 weeks course, and after a successful completion, course completion was approximated by this function, okay? Kind of similar to what you're gonna have for your quiz, okay? But, I just wanna look at this function with you, okay? To talk about why this may be appropriate, okay? So Desmos Graphing calculator. I'll graph this function and talk about it with you. So on the numerator, I have 7.5x over x squared plus 36 in the denominator. And I have this awkward tail plus 0.2. And I do have a domain restriction here that is going from 0 to, oh, hold on. I need to change this letter T to X on my paper, by the way. Hold on. And it goes up to 60. Okay. Let's see the graph. So that's the graph, but it's about, no, hold on, let me read the rest of it. Where t is in time, my variables are all messed up. I changed the letter to x. Where x is in time in weeks after the class started. So if x is 0, we're talking about before we start this class, okay? And if I say, like today, guys, is week 6, so x is 6 for today. I think it's 7 actually. But week 8 is when we finish. So when x is 8, you are done with this class. But I'm just gonna continue monitoring. Let's say that what if I keep on asking you this question about elasticity of demand over and over again until week 60, huh? And R of x is the proportion of students in the calculus class who could remember the elasticity of demand application. So will you remember it 1 year from now? But if you don't use it, you lose it. So I'm thinking this is going to go down from left to right. So take a look at this graph for me. I'm going to go ahead and just adjust the windows a little bit. 1 second. And then I'll make it that the x-axis goes from -2 to like 80. Okay. 80 weeks from now. Okay. Now look, that's the graph. So I'm thinking like week 0, about 20% of you may know about this in case you are repeating this, in case you took AP calculus or business calculus before. But as you are learning this in our online class, you'll read about this elasticity of demand in 3.7. More of you will know about this. And look at where the maximum happens. About week 6. Let's say that about 82.5% of you know about this knowledge after exam 3, okay? And then look what happens. You don't use it anymore. You don't talk about it anymore. So the proportion of students who remember this is going down. So about week 10, about 75% of the class, remembers it, and it just keeps going down, okay? So that's the function that I created to talk about this. Oopsies. And about week 60, what happened? Only 32% of the people will remember about this elasticity of demand. But that's what the function is talking about that I made up. And I think the one that you have is very similar because I just modeled mine right off of that. Okay, let's read part A. Part A will take the longest time. So after part A, I will come back and record part B and C later. But it is asking for what is the average proportion I highlight this word average. So do not, and I know people will do this, because that's what Chegg will tell you. Do not find R of whatever, okay, R of 8. That's wrong, okay? That if you simply find R of 8, you are finding the proportion of students in this class who remember about this elasticity knowledge at 8 weeks. That's not what part A is asking. It's asking for the average proportion. So don't find R of X. So if somebody find R of X and just plug it in and they just go like, okay, 8 here, and give me their answer, I know you're not listening, okay? Listen, okay? Because I don't want you to lose 6 points for just plugging in. Now, this is an application quiz on an integration section, integration chapter. So you will have to use integral to solve this problem. So how do you find an average of a function? That's from section 4.4. So you just wanted to stress that don't just find R of X. That is not what we are doing. We're finding the average proportion. In order to do that, let me write down, I'll say R average, looks like rave now, is equal to, I'll give you the formula from section 4.4. You will have to do 1 over B minus A, and B and A are just the bounds of this interval that you're looking at, okay? We are going from week 0 to the first 8 weeks. So if I write those down, A will be 0 and B will be 8 because we're going from week 0 to week 8, okay? So A is 0 and B is 8. If they want us to go all the way up to like week 12, then my B would have been 12, okay? All right, and then after finding that fraction, you will have to multiply this by the integral of A to B of the R of X, the function. So that is what you're going to have to do, okay? Not simply just plugging in 8 into R, and some incorrect sources online will tell you to do so, but don't listen to those. This is going to take some time, especially this part right here. Give me 1 second. This part right there is going to take us some time. So part A video will be longer, but part B, we're just using it. All right. Let's go ahead and find what the fraction is. So the fraction will be 1 over B minus 8. B is 8, A is 0. So if I do 8 minus 0, that's just going to be 1/8, okay? And I'm going to multiply this by the integral from what? 0 to 8 of that function, 7.5x over x squared plus 36 plus 0.2 dx. Now, what I will do is this. I will just focus on this part, this green boxed part. Okay? When I am done finding this green box part, guess what? I'm going to come back and divide my answer by 8. Okay? So let's just spend some time finding that green boxed part now. Okay? Let's see. I'll just find the indefinite integral and plug in 0 and 8 in there, okay? So what is integral of 7.5x over x squared plus 36 plus 0.2 dx? Okay, so I'll do that first, and then I'll plug in my bounds of 0 and 8. When I get my answer, I will divide that final, this green box part by 8, okay? So that may take us, oh no, this is such an ugly mess. It's going to take us some time. But let me separate this, okay? Because the second tail, the little 0.2 attached is easy. So I will separate this as 0.75x, x squared plus 36 dx plus integral of 0.2 dx, okay? So you understand what I just did, right? I separated this piece as the first, because that's going to be the harder one. And this is just going to be the easy breezy one, okay? So I'll do the orange and the yellow and I'll add them together, okay? If you look at the orange one, the first one right here, I can pull out what? The 7.5 out to the front. Let me pull this out to the front. I can go to the front. So I'll have 7.5 times integral of x over x squared plus 36 dx plus, now let's deal with this mess. That's super easy, isn't it? That is just going to be 0.2 x plus c, but I'll put plus c. Let me see, this is going okay, this is going well. Okay, so the purple one is done. It's just waiting for us. It's just waiting for the green piece to be done. But the green piece now, gosh, right? We have to use the this right there. We have to use the U-Substitution. So let's identify our pieces. Okay, so let U, and what I'm writing down here in brown is to deal with this brown box part. Okay, let U equals x squared plus 36. Then, if I take the derivative of both sides with respect to x to find du dx, that's going to give me 2x. Well, which means du is 2x dx, right? But look at what I want to substitute. I want to make x dx 1x dx. Well, I have 2x dx. So what I have here is twice as big as what I actually want. So how do I match this? I'm going to just take half of 2x dx so that I can get 1x dx. Makes sense, right? So I'll divide both sides by 2 or put half. So I will have half du equals x dx. Now I am ready to do my substitution. X dx is half du, and this in the bottom, this x squared plus 36, is what I decided to call u. So we are ready to do the u substitution, okay? It's like we have parts after part, like all these subparts. So 7.5 times integral of what's this going to turn into? I will put, oh, it's going to be ugly, half du on top of the fraction. Okay, that's what the green piece is, right? The green is half du. And in the bottom of the fraction, I will have my u. Okay, and you can just keep on copying this down. This one isn't really going to do anything. We're just gonna bring it down. This is just all done, waiting for this green part to be done. So let me keep on going with this green piece, 7.5. Let's make it a little bit prettier though. This is such a mess. I have half right there. But listen, you know what? Let's pull out that half. Let's just bring this half out so that it can join that 7.5 in the front. Go join that for a while these u and du's are going to get integrated. So half of 7.5. You know what? I like the decimal, so I'm going to try to keep it as decimal. So 7.5 divided by 2. It's what? 3.75 integral of. Now, inside, I will rewrite this. You notice that u is in the bottom of the fraction. You can write this as u to the negative first power and du. Okay, now bring this down. Exactly the same. All right, I'm going to attach a new paper. Guys, I write big. You know that, or I write a lot. So that's why I always need like extra paper after paper. But I am almost done. I am almost done with this. I have 3.75. And let's finally attack this. Let's finally do this. What's that going to be? Oh, you know it, right? That is natural log of, well, absolute value of u. Okay. I technically do that. I think I forgot to do that yesterday. And then we bring this down. But do not forget, this is u. We need it back in terms of x. So what was x? So that's what we substituted. So we need to plug that back in for u, okay? So that is going to be equal to 3.75 times natural log of. But hey, look, I think I'm just going to get rid of this absolute value bars because when you square a value, that's going to stay positive anyways, right? So it's just going to be positive. So I'll say natural log of x squared plus 36. And then, oh, well, technically plus c. Okay, plus c technically. Not going to take points off if you don't put two double plus c's. But now I finally got it. I finally found the antiderivative. It is 3.75 times natural log of x squared plus 36 plus 0.2x. But look, this plus c's, if you add a c and another c, that's just another constant. But now this is our good time. This is good time for us to plug in those bounds. What were the bounds? So long ago, 0 and 8. So I'm going to plug in 0 and 8 into this expression, and I will subtract them. That is how you can find, not even the final answer yet, right? That is how we're going to find this green box part. Okay, so let's go ahead and do the bounds now. This is difficult. All right, so if I plug in 8, I will get 3.75 times natural log of 8 squared plus 36 plus 0.2 times 8. So whatever I get here, I will subtract this by 3.75 times natural log of 0 squared plus 36 plus 0.2 times 0. I'm going to find this green and the pink, and I will subtract them, okay? Oh, I can see the end of the tunnel now. So I need a calculator for this. See, guys, this is the amount of work required for this problem. So if somebody just decides to plug in, that's not going to be enough, right? Okay. 3.75 times natural log of 8 squared plus 36 plus 0.2 times 8. So the first number came out to be 18.869. I'll just round it to the nearest thousand. And then the next line, the pink one, if I substitute 0 in, what will that be?
How about spaghetti?
You want to eat some spaghetti?
Yeah.
Or hold on, let mommy finish this one. 13.438. All right, let us subtract those two answers now, okay? So if I subtract them, subtract. Yeah, I'm getting distracted. To get subtract this number. And for this quiz, these quizzes are not timed, so you know you guys take your time. All right, if I do that, I get 5.43. Okay, 5.43, and by about I almost freaked out. Okay, I almost freaked out. Okay, so listen, I freaked out because we are talking about proportionate people, right? Okay, the average proportion of people. 5.43 is 543% of students remembering it. But proportion cannot be over 100%. If I only teach 20 of you, I'm not going to magically have like 1,000 people remembering this stuff, or, or like 50 people or whatever the number is. So I almost freaked out, but I remember the very last part that I have to do. Remember what we just found. Okay, the 5 point, what was that number? 5.43. 5.43 is just that integral. Okay, oh, wow, okay. Now, what's the final thing we need to do? We need to divide by 8, right? And that is going to be the final answer. So hold on. I'll bring this down and then I'll write my final answer. I'll go eat some spaghetti and then I'll come back and show you the second part. Okay, so this becomes 1/8 times 5.43. Please be a number smaller than 1. Please be a number smaller than 1 so that it can be a proportion. All right. If it is not, then I just made a problem that doesn't make sense. 5.43. Ah, yes. So the average proportion of students who will remember this elasticity of demand knowledge in the first 8 weeks of our class, hey, that's more than half of you. 0.67. I'll just say like 0.68. About 68% on average. And you can write down the wording of it, but if I can see that work, I will be very impressed and I will be very, very happy, because if you can do this, that means you know how to find the average function value using definite integral, and also know how to use the U-substitution beautifully to solve for that definite integral. So wow, that's why the answer is, they're asking for the average, and this is what you're going to have to do. So do not just find R of 8, because that is not the average proportion, okay? All right, so that's been a while. That took us a long time. So, but after that, it's going to be easy. I'm just going to have to come back and show you part B. And I may just ask you to think about your answer for part C yourself, because that's just it's an extra question. But I'll be back. I'm going to go eat lunch. And I think I can come back and do part B a little bit later, okay?